The traditional smartphone alarm is a relic. By 2035, you wake up because environmental biometrics built into your room quietly detect the end of your REM cycle, adjusting the ambient light and temperature to bring you to consciousness naturally. To understand how we connect to this invisible network, look at how brain-computer interfaces, or BCIs, have evolved. What used to be highly experimental lab hardware is now an accessible clinical procedure, complete with consumer-facing public registries. Instead of popping pills, health maintenance relies heavily on in vivo CRISPR therapy. Using lipid nanoparticles, essentially tiny targeted fat bubbles, genetic instructions are delivered directly inside your cells to repair flawed DNA sequences and prevent chronic diseases before they manifest. Medicine is no longer a reactionary system designed to treat you once you're sick. It functions as a proactive daily protocol that chemically and genetically manages a perfected baseline of human health. Stepping outside, the traditional traffic light is extinct. Surface streets operate entirely on algorithmic flow control. Subscription-based autonomous pods constantly communicate with the municipal grid, allowing vehicles to seamlessly weave past one another at intersections without ever coming to a halt. Even with optimal surface routing, the sheer density of a modern megacity requires another dimension. That demand is absorbed by electric vertical takeoff and landing aircraft, or EVTOLs, acting as high-volume air taxis operating quietly above the skyline. This bar chart compares standard 2024 battery capacities against a critical engineering threshold. For commercial air taxis to operate efficiently, battery energy density had to surpass 400 watt-hours per kilogram. Hitting that mark eliminated range anxiety and made rapid, consecutive short-haul flights economically viable. The daily commute is no longer a physical barrier or a test of patience. It functions as a quiet, frictionless three-dimensional transit network running in the background of daily life. Back in 2024, generative AI was largely a utility for creating text or images. Fast forward a decade, and corporate software has evolved into agentic AI. These systems act as autonomous colleagues, capable of executing complex, multi-step corporate strategies with near-zero human supervision. Because algorithms now handle the routine administrative grunt work, entry-level positions require traditionally senior-level skills. A new hire today isn't formatting data. They act as a strategic director from day one, managing a fleet of specialized AI agents. On this chart, China's declining labor force intersects a rising bar graph of humanoid robotics deployments. Seizing a 37 million worker shortfall due to demographic collapse, integrating bipedal robots became necessary. As unit costs plummet toward $15,000, synthetic labor becomes vastly cheaper for unstructured tasks. With machines supplying both the cognitive processing power and the physical muscle, the primary value of a human worker is now anchored in empathy, creative problem-solving, and strict ethical oversight. Orchestrating this planetary automation requires an invisible logistical backbone situated just above the atmosphere. The space economy is now valued at nearly $1.8 trillion, with the vast majority driven by Earthbound industries relying on low Earth orbit constellations for precise global positioning and high-speed data transfer. While the commercial sector saturates orbital space, international space agencies are finalizing alliances for the first human orbital flights to the Martian sphere. Down on the surface, keeping this entire digital architecture online presents a massive physical constraint. The hundreds of thousands of interconnected AI data centers demand roughly 1.5 trillion kilowatt-hours of electricity annually, placing extreme strain on global power grids. Traditional carbon capture technologies proved far too inefficient to offset this demand. Instead, the solution relies on rapid, shear-force renewable electrification, alongside the initial operation of enormous commercial-scale nuclear fusion prototypes designed to eventually deliver limitless clean energy. The expansion of our computational power relies entirely on our ability to completely rewire the planet's energy infrastructure before the legacy grid buckles under the load. The sheer speed of this technological turnover has killed standardized cohort-based education. With 44% of core workforce skills undergoing constant disruption, professionals are forced into daily, hyper-personalized virtual reality upskilling sessions just to avoid obsolescence. This constant state of flux breeds intense societal anxiety. global risk experts warn that the unchecked proliferation of AI-generated misinformation is actively eroding institutional trust, creating deep political polarization and an increasingly volatile public sphere. That volatility makes our hyper-connected infrastructure incredibly fragile. In a fully integrated smart city, a single sophisticated state-sponsored cyber attack could simultaneously paralyze algorithmic transport networks, disable regional power grids, and contaminate municipal water supplies. Economically, an aggressive two-track job market has taken hold. Those who successfully adopt to managing agentic AI see rapid wage growth, while millions of workers performing easily automated administrative or physical tasks face the threat of permanent displacement. Beneath the frictionless daily commute and the tailored genetic therapies lies a remarkably fragile civilization, one where the speed of innovation constantly outpaces our ability to build protective guardrails. The defining characteristic of the 2030s is the absolute convergence of different technological vectors: targeted biological editing, the mass deployment of a synthetic robotic workforce, and the aggressive electrification of the global economy. We successfully engineered tools to overcome our most stubborn physical and biological limitations. Yet in doing so, we exposed just how delicate our political structures, economic models, and social contracts truly are. Pause for effect. The architecture of this future isn't theoretical. The hardware is being assembled right now. The question is whether we will develop the human wisdom required to survive the very world we are racing to build.